This is section 6.3, part B, Binomial Probability. In a binomial setting, we can define a random variable, let's say x, as the number of successes in n independent trials. What's the probability distribution of x? Let's see if an example can help shed some light on this question. So each child of a particular pair of parents has a probability of 0.25 of having type O blood. Genetics say that children receive genes from each of their parents independently. If these parents have 5 children, the count x of children with type O blood of a binomial random variable with n equals 5 trials and the probability of success for each child being 25%. In this setting, a child with type O blood is a success and a child that does not have type O blood is considered a failure. What's the probability that x equals 0 or none of their children have type O blood? So it's the chance that all 5 children do not have type O blood. The probability that any one of this couple's children does not have type O blood is 1 minus the probability of success, because remember, probability of success and failure together should add up to 100%. So we can do 1 minus 0.25, and that tells us 0.75. So there's a 75% chance that each child independently will not have type O blood. So the probability of all 5 of them not having type O blood would be 0.75 times 0.75. You're going to multiply all of these together by the multiplication rule of independent events. Or we can say 0.75 raised to the 5th power, which would be 0.2373. So there is about a 24% chance that if they have 5 children, none of them will have type O blood. Each child of a particular pair of parents still has 25% chance of having type O blood, but this time we want to find the probability that exactly one of them has type O blood. Now, we have to think about the order in which this could happen. So the first child could have type O blood, and the next 4 could not have type O blood. So that'd be 0.25 times 0.75, 0.75, 0.75, 0.75, or 0.25 times 0.75 to the 4th power. If the second child has type O blood, you would do the same thing, but it'd be 0.7 times 0.25, and then 75, 75, 75. Or again, it'd be 0.25 times 0.75 to the 4th power. It could be the 3rd child that has type O blood, the 4th child, or it could be the 5th child. In all, there are 5 different ways that exactly one child can have type O blood, and each of them have the same probability. So the probability that there's exactly one child that has type O blood is the probability that the first child has type O blood plus the probability the second one has type O blood plus the 3rd, 4th, or 5th. Or we can write this as 5 times the probability that they have 1 type O blood person and 4 who are not. So 5 times 0.25 times 0.75 to the 4th power, which will give us about 40%. So there is about a 40% chance that exactly one of the couple's 5 children will have type O blood. Now let's continue with a scenario, but this time we're going to look for 2 children that have type O blood, and exactly 2 children. So it could be the first 2 children, it could be the 1st and the 3rd, the 1st and the 4th, the 1st and the 5th, it could be the 2nd and the 3rd. There's a bunch of different combinations. Now we do know that this probability that 2 of them will have type O and 3 of them will not can be found by doing 0.25 squared times 0.75 to the 3rd. But then you have to figure out how many different arrangements you can do this. And it does turn out that there are 10 different arrangements of 2 successes and 3 failures. So we can do 10 times 0.25 squared times 0.75 squared, and that gives us a 26% chance that exactly 2 of them will have type O blood. The pattern of this calculation works for any binomial probability. So the probability that x is k is equal to the probability of exactly k successes in n trials. To find this, the number of arrangements is going to be P, it's the number of arrangements, times P raised to the K times 1 minus P raised to the N minus K. So you are going to have to know the number of arrangements. In the last one, there were 10 arrangements. We multiplied that by the probability of success, which was 0.25, times the number of times we expected successes. And then 1 minus P is the probability of failure, which in this case was 0.75, raised to the number of trials minus the number of successes. So we had 5 trials, we had 2 successes, so that leaves us with a 3. So that's how we're going to get that equation. So to use this formula, we must count the number of arrangements of K successes and N observations. This number is called the binomial coefficient. We use the following fact to do the counting without actually having to list all of those arrangements. So the number of ways of arranging K successes among N observation is that binomial coefficient. So N given K is equal to N factorial over K factorial times N minus K factorial. And you do need to know that N factorial is just N times N minus 1 times N minus 2. So let's say we have 5 factorial, that would just be 5 times 4 times 3 times 2 times 1. And we do know that 0 factorial does equal 1. So like we just said, to find that factorial, you're just going to multiply whatever number you have by each number that follows it all the way up to 1. The larger the 2 factorials in the denominator of the binomial coefficient will cancel much of the n factorial in the numerator. So if we look at this, we had 5 kids total, and we were expecting exactly 2 of them to be type O blood. So it's going to be 5 factorial over 2 factorial times 3 factorial. So 5 factorial is 5 times 4 times 3 times 2 times 1. 2 factorial is 2 times 1. And 3 factorial is 3 times 2 times 1. So we can cancel out those 3s, 2s, and 1s. So that's just going to give us 5 times 4, which is 20, over 2 times 1, which is 2. And 20 divided by 2 gives us 10. Now, the binomial of 5 over 2 is not related to the fraction of 5 halves. A helpful way to remember this is to read it as 5 choose 2. Binomial coefficients have many uses, but we are interested in them only as an aid to find the binomial probability right now. Now, you can find this value without having to do those factorials by hand on your calculator. So to calculate a binomial coefficient, like 5 choose 2 on your calculator, you are going to hit the math button. You're going to go over to probability, or PRB, and you're going to choose option 3, which is NCR. So NCR basically tells you the number of trials. You care about the order in which they have them. So the first child have I type O blood is different than the third child. And then R is telling you the number of successes. And you're going to press enter. So we're going to type 5. And before the C, the 2 will go after the C. And then you will just hit enter to run the command. And you should get that there will be 10 different ways you can do that. So the binomial coefficient, n over k, counts the number of different ways in which k successes can be arranged among n trials. The binomial probability of x equals k, is this count multiplied by the probability of any one specific arrangement of k successes. So our formula to find this, our probability of x equals k, is just the number of arrangements of n choose k times the probability of success raised to the number of successes times the probability of failure, or 1 minus k, raised to the number of trials minus the number of successes. So let's find the probability that exactly 3 of these children have type O blood. So we're finding the probability that x is 3. To do this, we know we have 5 children. We're going to choose 3 of them to have type O blood. So we're going to do 0.25, the success probability is 25%. For 3 children, the probability of failure is 75%. If they have 5 kids and 3 of them are successes, then 2 of them would be failures. Now, we need to determine the number of arrangements that we can get. So remember, you are going to hit that math button. You're going to go over to probability, and you are going to select NCR. Our number of trials is 5. The number of successes is 3. And if you calculate that, you will see there are 10 different arrangements. So if you put that into your calculator, you are going to get that the probability is 0.08789, or the probability of having exactly 3 children that have type O blood is about 9%. Should the parents be surprised if more than 3 of their children have type O blood? Justify your answer. So the probability that they have more than 3 is the same thing as the probability as x is equal to 4 plus the probability that x is equal to 5. So we can do both of those calculations. We're going to let x equal 4 and x equal 5, find both probabilities, and then we can add them together. So the probability that x is 4 is going to be 5, choose 4. We have 4 successes and 1 failure. So if we do that 5, choose 4, we will see that there are 5 different arrangements. And we're going to do 5 times that 0.25 raised to the 4th power times 0.75 raised to the 1st power. And we're going to find the probability of exactly 4 children to be 0.0146. If we find the probability that all 5 of them are, so 5, choose 5, there is only one way all 5 of them can have type O blood, because all 5 of them have type O blood. So we would just do 1 times 0.25 to the 5th power, and anything raised to the 0 power is just 1, so we can just do 1 times 0.25 raised to that 5th power, and you are going to get 0.000976. So if we add those two probabilities together, we're going to get about a 0.01563, or there's only about a 1.6% chance that more than 3 of their children will have type O blood. So the parents should definitely be surprised if this happens. We can also use the calculator's Binomial Pdf or Binomial CDF commands to perform calculations in that previous example. So there are 2 handy commands that you can use on your calculator. If you are looking for exactly the number of trials, so if you're looking for when x equals k, you can use the Binomial Pdf function. If you are looking for x is less than or equal to k, you can use the Binomial CDF function. So if you are trying to find, again, instead of having to do the calculation by hand, the probability that x equals 3, that equals exactly 3, you are first going to hit second vars, and you are going to go down until you find Binomial Pdf. And you're going to have to go down past options 1 through 9 to 0, and this is going to be option A. Our number of trials is 5. Our probability of success is 0.25. Our number of successes is 3. And then if you hit enter, the calculator will give you a probability of 0.087. So this calculator can do this for you. Now, if we need to find the probability that x is greater than 3, that's just 1 minus the probability that's less than or equal to 3. So if we want to find the probability that it's less than or equal to 3, you can hit second vars to get that distribution. You're going to go down until you find Binomial CDF. Our number of trials is 5. Our probability of success is 0.25. Our x value is 3. So the probability that x is less than or equal to 3 is 0.984375. To find the probability that it is more than 3, we would just do the 1 minus that 0.984375, and that will give you that about 1.6%. Of course, you could have just found exactly 4 and exactly 5 and added those two together as well. So when you go to take your AP exam, do not rely on calculator speak when showing your work for a free response question. So if you write Binomial Pdf 5, 0.25, 3 equals 0.08, that will not earn you full credit for a binomial probability calculation. At the very least, you must indicate what each of those values represents. So this is when n equals 5, p equals 0.25, and k equals 3. Better yet, show the binomial probability formula that we actually used before that, where you're going to plug in the numbers yourself. So let's check our understanding. To introduce her class to binomial distributions, Mrs. Daisy gives a 10-item multiple choice quiz. The catch is students must simply guess an answer, A through E, for each question. The teacher uses the computer's random number generator to produce the answer key, so that each possible answer has an equal chance of being chosen. Patty is one of the students in this class. Let X equal the number of Patty's correct guesses. So show that X is a binomial random variable. Remember, to do this, you have to check the bins. B stands for binary, and our success would be that she gets the question correct. Failure would be she gets it incorrect. I is independent. Since the calculator is randomly assigning whether the answer to the question, each one of them will be independent. So one question does not affect the other, so each trial is independent. N is the number of trials. We do know that it is a 10-question quiz, so the number of trials is set in advance. And S is the probability of success. Since the options can be A through E, each question has 5 different answers, and each answer has a 20% chance of being correct since the computer is randomly generating the answers. This is a binomial setting since X counts the number of successes, and it is a binomial random variable where n equals 10 and p equals 0.2 or 20%. Now find the probability that X equals 3. Explain what this result means. Now I'm going to do it by hand, and then I will explain how to do it on the calculator. So if p is 3, remember there are 10 options. We're choosing 10 questions or 10 trials. We're choosing that 3 of them are correct. Now the chance of success is 20%, and that's going to happen 3 times. The probability of failure, remember, is 1 minus the probability of success. If you were successful 20% of the time, then you would get it wrong 80% of the time. And this is going to count for the rest of the questions. So if there are 10 questions and you got 3 correct, that means you are going to get 7 wrong. Now to figure out how many different combinations we can do, you can hit the math button, go over to probability, and select NCR. We know there are 10 trials, and 3 of the times you get it correct. So there are 120 different combinations in which you can do that. So if we do 120 times 0.2 raised to the 3rd power times 0.8 raised to the 7th power, we're going to see that the probability that you get exactly 3 questions correct would be 20%. Now, because this is X equals 3, on your calculator, if you want the calculator to do all the work for you, you will select that Binomial Pdf. The number of trials is 10, the probability of success is 20%, and you are selecting that you want her to have 3 questions correct. So that would be that there is a 20% chance that Patty will answer exactly 3 questions correctly. To get a passing score on the quiz, a student must guess correctly on at least 6 times. Would you be surprised if Patty earns a passing score? Compute an appropriate probability to support your answer. Now, this means she needs to get a score that is greater, she needs to get more than 5 correct, or she needs to get 6 or more correct. So this means she can get 6 of them right, 7, 8, 9, or she can get all 10 of them correct. You can do those in the calculator separately, or remember, you can find the probability that x is less than or equal to 5, and then you can do 1 minus that probability. Sorry, this should be a 5, to find the probability that it is greater than that. You can do whatever way you want. You can do it either on the calculator or you can do part of it by hand. But this is going to give you a 0.006 or a 0.6% chance that Patty will score a passing score. So you should be surprised if she passes this quiz.